Hi everyone, it's Math with AUB. Let's embark upon the course of preparation for the NTHP basic mathematics known as quantitative mathematics. Quantitative mathematics. In this day number one, I have started from the topic power and roots, exponents. Just get along. What is first question? First question reads as a raised negative 1 over 2 is equal to 3. A raised negative 1 over 2 is equal to 3. How to make exponent positive? That is the tip in that question to be solved very easily. 1 is always there. Reciprocal the base. Write the multiplicative inverse of the base. You are going to have power positive. It is tantamount to 1 over a raised positive 1 over 2 is equal to 3. How we have converted negative power to positive? Make base reciprocal or multiplicative inverse. Now 1 over 2 means under root 1 over a is equal to 3. Square root of 1 is 1. Square root of 1 is 1. Under root a is equal to 3. We are interested in the value of a. Shift them. 1 over 3 is equal to under root a. Now eventually we have to got rid of this squaring both sides. It is equal to 1 over 3 square under root square root a square. Cancelled out. Square of 1 is 1, square of 3 is 9. So that is the value of a. That is 1 over 9 in that case. That is 1 over 9 in that case. It's our question number 1. What is trick behind this? Let's see and find out. Let me give you another example. X over y raised negative m. How we have to make this power positive, exponent positive? Just reciprocal the base. Write the multiplicative inverse of the base. Y over x raised positive m. Raised positive. That is the strategy or tip behind solving these questions. Okay, move to question number 2. Move to question number 2. Question number reads as 1 square plus 1 raised 4 plus 1 raised 6 plus 1 raised 8 up to 1 raised 50. Let me write question number 2 for you. That's all. 1 square, 1 raised 4, 1 raised 6 up to 3 dots show the continuity 1 raised 50. They are not total 50. We have taken only even powers 2, 4, 6, 8, 10, 12. Even powers, even from 1 to 50, half or even, half or odd. So here these total number are 1, 1, 1. We have to add 25 times. 25 times. If you add 1 plus 1 plus 1 25 times, we are going to have 25. That's the idea behind this, or we have cracked the nut. It's not 50 times. Even powers are only given to us. 1 is 1 raised 2, 1 raised 4, 1 raised 6. Only even powers. 2, 4, 6 up to 50 means from the first 50, half are even, half are odd. So 1 plus 1 plus 1 is equal to 25 times, because 1 is raised to any power gives us 1. 1 raised to any power gives us 1. So 25 is our answer in that case. Let me write question number 3 for you. I have space here. Let me manage. Question number 3. That is 4 raised to n plus 3 is equal to 8 raised 9 plus 5. Just base is 4 and here base is 8. Both are the powers of 2. 4 can be written as 2 square times 2n plus 3 and 8 2 raised cube times n plus 5. Now bases are equal, equality symbol is there, bases are equal, equality symbol is there, therefore powers are equal. Just simply manipulate the powers. 2 raised 2 to the 4n, 2 3 the 6. It will become 2 raised 3n, 3 5 the 15. Bases are equal, powers are equal. 4n plus 6 is equal to 3n plus 15. Solve for n. Shift quantities, like terms, n terms on the left hand side, constant on the right hand side. We have 4n minus 3n is equal to 15 minus 6. So n is equal to 9 in that case. n is equal to 9 in that case. Exponential equations make the base same. Therefore, there is 8. These two are basically powers of 2. Powers of 2. 4 can be written as 2 square. 8 can be written as 2 cube. That's the tip behind this. Equality symbol prevails. Bases are equal. Therefore, powers are equal, and you can manipulate. We have solved question number 1, 2, and 3. Let's see question number 4. Question number 4. It reads 2 raised x divided by 2 raised y is equal to 2 raised 3. Then x in terms of the other are make x subject. Question number 4, that is 2 raised x over 2 raised y is equal to 2 raised 3. Find x. Find x in terms of or solve for x or make x subject. Bases are same, they are individual. Subtract lower power from upper power to reach 2 raised something. 2 raised x minus y is equal to 2 raised 3. Bases are same. We are in a position either we can write 2 raised y minus x or 2 raised x minus y. Here 2 is in the numerator, that's why we have shifted y in the numerator by using exponent law. Bases are equal, therefore powers are equal. X minus y is equal to 3. We are asked to find value of x, make x subject. So x is equal to shift y on the right hand side, it will become 3 plus y. So value of x is 3 plus y in that case. X is equal to 3 plus y or y plus 3 or option number A in that case. Question number 5, we have question number 5. 3 raised x is equal to 10. If the given part of the problem, it is given to us, if 3 raised x is equal to 10, then what is the value of, we have to find out value of 3 raised x minus 3. 3 raised x minus 3. 3 raised x minus 3 can be written as 3 raised x times 3 raised minus 3. 3 raised x minus 3 can be written as 3 raised x times 3 raised minus 3. Bases are same, we can add the powers, we will get the same thing. Now we have the value of 3 raised x. Instead of this quantity, I can write 10. 10 times 3 raised negative 3. Make the power positive, make the exponent positive. I can write 10 over 3 raised to 3. 3 raised 3 means 3 into 3 into 3. We are going to have 10 over 27. 3 3 the 9, 9 3 the 27. So 10 over 27 is the right option in that case. We have solved question number 5. Now 6, 7, 8, 3 are remaining. Let's move to question number 6 one. A good one, a tricky one, but simple one as well. Question number 6 reads as, if x raised to x square times y cube, x square times y cube is equal to 10 and x cube times y square is equal to 8, then what is the value of x raised 5 times y raised 5? We have given if part, question number 6. Question number 6, given part, x square times y cube is equal to 10 and x cube times y square is equal to 8. We are asked to find x raised 5 times y raised 5. Look at this, if we multiply both the expressions, let me write them. X square y cube is equal to 10 and second one is x cube y square times 8. If we multiply these both equations, x square times x cube, it will become x5, y cube times y square, it will become y. Just simply multiply them. X raised 5, it will become y raised 5 10 times 8. So x raised 5 times y raised 5 is equal to 80 in that case. So our answer is 80 in that case. 80 in that case. Question number 7 and 8, the most elegant question from all these 8 questions. Let me solve them one by one in a good space, in open space. Erasing this, we have question number 7. Question number 7. If a and b are positive integers, then we have to find out the greatest one from this one. A and b are positive. A is positive integer as well as b is also positive even integer. Positive even integer. Positive even integer. Then which one is the greatest? Number 1. A option is minus 2 raised 2 times a raised b, as power is even. as b is positive even integer, as b is positive even integer, so minus will be no more in the base. It is 2 raised b is equal to a raised b. We have this. What about the second one? This b, let me take b, minus 2 times a raised 2 times b. As power is even, b is even times any number, result is even. So minus will be neutralized, distribute the power, 2 raised 2b, a raised 2 times b. Now this one can be written as 2 square raised b times a raised 2b. 2 square means 4 raised b times a raised 2b. It's our option number B. Question number C, or C is 2 raised b, 2a raised b. It is tantamount to 2 raised b, a raised b. What about the last one? It's tiny one. Now we have to compare which one is the greatest. Which one is the greatest? Look, that's our simple one. 2 raised b, a raised b times. That it is going to be the most one, as a and b are both positive and even integer. Both positive and it is the greatest quantity. It is the greatest quantity. It is the greatest quantity. So our option number B is the right option in that case. Option number B. Question number last but not least. If x square is equal to y cube, then for what value of z, x raised 3z is equal to y raised 9. Y raised 9. We are interested in the value of z. Find z. Find z. Given pot, x square is equal to y cube. X square is equal to y cube. So we have to manage y cube here in order to replace x square. X raised 3z. Okay, let me erase it in order to give you good view. Good view. X square is equal to y cube. We have to manipulate x raised 3z is equal to y9. We can manage y cube here. X raised 3z, y9 can be written as y cube times 3. 3 3 is 9. Instead of y cube, we can replace x square here. That's the trick behind this. X raised 3z, instead of y cube, we write x square. Power having another power, multiply the power, x raised 3z is equal to x 2 3 the 6. Bases are equal, therefore powers are equal. 3z is equal to 6, or z is equal to 6 over 3. So z is equal to 2 in that case. That is equal to 2 in that case. It's my tiny effort to explain to you the basics of power and roots. It's all by itself. Next.